Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I will be going over exponents and their properties. Let's get started. Exponents are super useful in math and algebra, and calculus, and statistics, and basically any form of math that you do. Exponents are used all the time, and you're going to see them a lot. So, what is an exponent? An exponent is basically a way to express a large number in terms of powers. So in an exponent, let's put 10, actually let's put 3 to the power of 5. So 3 in this case is our base. This is the number that we're going to keep multiplying. 5 is our exponent. This tells me that I'm going to multiply 3 by itself 5 times. So I'm going to do 3 times 3 times 3 times 3 times 3, meaning I multiply 3 by 3 itself 5 times. 1, 2, 3, 4, 5. And 3 to the power of 5 is, just doing that on my calculator, 243. That's a really big number. Well, not super big. It could be bigger, but still pretty large. But that's just one other way of writing it. So that's a basic definition of what exponents are, pretty much. And now let's get into their properties. Our first property is let's start nice and easy. Let's do the product property of exponents. So in the product property of exponents, I'm going to give an example. Let's say we did 3 to the power of 5 times 3 to the power of 6. What would that equal? Well, the product property of exponents tell us when we have common base, meaning you're multiplying with a base of 3, right? So the 3 doesn't change, only the exponent changes in what you're multiplying. When there's a common base and though that is being multiplied, then you can add their exponents. To simplify. So 3 to the power of 5 times 3 to the power of 6 can be written as 3 to the power of 5 plus 6. And it could be written to 3 to the power of 11. That is the product property of exponents. And with no matter how many common bases you're multiplying, could be 2 like in this example, could be 10, it could be 20, it could be 100. No matter how many, you can always add the exponents and simplify. And let's say we did 3 times 3 to the power of 5 times 3 to the power of 6. 3 doesn't really have an exponent on it. Does it say the same? No, it does not. There is an invisible 1. That 1 basically any number to the power of 1 is itself. 10 to the power of 1 is 1. 5 to the power of 1 is 1. 1,000,000 to the power of 1 is still 1,000,000. So 3 to the power of 1 is 3. So 3 to the power of 1 plus 5 plus 6. And now that would be 3 to the power of 12. Now that is a much bigger number than 3 to the power of 5. 3 to the power of 12 is actually 531,441. Pretty big number. So that is the product property of exponents. Moving on, let us do now the power of a power property of exponents, or more simple, power property. So we did the product property, now we're doing the power property. So the power property tells us that if we have, for example, 3 to the power of 5, and we wanted to raise that to a power, so we wanted to raise that to the power of 2, let's say, that allows us to multiply the exponent. So when we are raising a base, when we're raising a power to a power, then you multiply the powers. When you're raising an exponent to a power, multiply the powers. So 3 to the power of 5 and that to the power of 2 can be rewritten as 3 to the power of 5 times 2, which is equal to 3 to the power of 10. Now let's say we had like another layer, and this was raised to the power of 3. Easy. All you do, multiply 3. So you do 5 times 2 times 3. And that would be rewritten as 3 to the power of 30. And so on. Easy enough. It's just important to recognize when you could use this when simplifying an expression. Next is the quotient property of exponents. So that tells us when we have, let's say, 3 over 5 to the power over divided 3 to the power of 3, we could do 3 to the power of 5 minus 3. That gives us 3 to the power of 2. Meaning, when we are dividing common bases, you can subtract their powers. It's as easy as that, because 5 is the power in the numerator, 3 is the power in the denominator. The power on the top is always the one is subtracting the power on the bottom. 5 minus 3 is 2. So that could be rewritten as 3 to the power of 2. Very easy. Very simple. Next, the zero property of exponents. That means any number to the power of 0 or raised to the power of 0 or the 0th power, that's equal to 1. Oh. So, if we wanted to do 3 to the power of 0, that's 1. 10 to the power of 0, 1. 1 to the power of 0, 1. 3 to the power of, I already did that one. Oops. 13 to the power of 0, 13 to the power of 0, 1. 100 to the power of 0, 1. 1 million to the power of 0, 1. That's it. It's as easy as that. You see any number to the power of 0, automatically equal to 1. You know that right away. Now, fifth property, the negative property of exponents. This tells us if we have a negative exponent, like 3 to the power of -5, this can be rewritten as a fraction with 3 to the power of 5 to the power of +5. So when you have negative exponent, it could be rewritten as a fraction with a denominator of the base with the positive exponent, and that is under 1. Always. Always, always, always under 1. So in this example, we did 3 to the -5 power. We could also do 11 to the power of -11. That would be rewritten as 1 over 11 to the power of 11. That's all. Now, we did the negative, we did the quotient, we did the 0 property, we did the product property, and we did the power property. Now, our sixth property is going to be the power of a product property of exponents. Power of a product property. This means when we have AB to the power of n, that can also be rewritten as A to the power of n times B to the power of n. It's almost like you're distributing that power. Now, it doesn't work in every scenario, but it could be useful when it can be applied. So with the real number example, let's say we had 3x to the power of 2. It can also be rewritten as 9x squared, right? Because 3 to the power of 2 times x to the power of 2. 3 to the power of 2 is 9, x to the power of 2 is x squared, 9x squared. And if we were to actually solve this regularly, 3x times 3x, this could be rewritten using the commutative property, 3 times 3 times x, associative property, 3 times 3 is 9, x times x, that's x squared because of a property we did earlier, the product property of exponents, because this is technically x to the 1 times x to the 1, and that's x to the power of 1 plus 1, which is equal to x to the power of 2. Boom. Finally, we have the power of a quotient property of exponents. So the property of a quotient, the power of a quotient property is basically if you have a over b to the power of n, you could write that as a to the n over b to the n. And once again, you could substitute that with numbers. Let's say you had 3 over x to the power of 2. That could also be written as 9 over x squared, or 3 squared over x squared. It's as easy as that. So in this video, we went over 7 exponent properties. Those are the product property, the power property, the quotient property, the zero property, the negative property, the power of a product property, and the power of a quotient property of exponents. They describe how we can use exponents to simplify algebraic equations and how they can be useful in interpreting negative exponents and zero exponents. Thank you so much for watching. I hope this video was helpful, and I wish you luck in your studies. Bye!